This is the OSI Model physical layer where we cover basic Linux networking commands. So in this exercise we will be executing the ifstat command, and this reports on interface statistics from your device as it is connected to this virtual machine. So to display network interface statistics, the physical layer of the OSI model sends data as signals over a physical medium. So the ifstat command utility is designed to report very simple statistics from all of the different interfaces that are connected to your physical medium. So like your local laptop is physically connected to an interface which is then connected to a network. Your virtual machine through virtual interfaces is using the physical interfaces of your laptop or PC that you are running your virtual machine on. So to simply demonstrate this command, if I just type ifstat here, you will see right here it starts to display some very simple statistics. If I just hit Control-C on my keyboard, it stops collecting and printing those statistics. So here, if you look at the output of the ifstat command, you'll see an interface at the top labeled ENP0S3, and then underneath that you will see a list of columns, and on the left is all of the data that are moving into the interface. It's measured in kilobytes per second. And then the second column there lists anything going out. So since I wasn't transmitting any data over my interface ENP0S3, it shows 0K. But on the left column, you can see that I was receiving and listening, actively listening and receiving requests that were available over my interface from the network, over my interface ENP0S3 from my locally connected network. This is of the OSI model data link layer. So Linux has a built-in utility called IP that can be used to display network information. So it's important for any network professional to understand how to view network information using command line utilities, because many of the network devices use this type of interface as opposed to graphical interfaces. So type man IP, it gives you the manual and all of the documentation related to IP. You can just hit return to continue to go through that. You can look at the different options or command line arguments for the IP command. So I'm just going to hit Q to quit. So what we're going to do is from the command prompt here, we're just going to type IP space address and observe the output of this IP command. And you can type this from any directory no matter where you're at in your virtual machine. So looking at the output of IP address, there are two interfaces available labeled 1 and 2, and specifically labeled in 1 is LO. This is what's called the loopback interface. And how do I know that? If you look here, you'll see that its IP address is 127.0.0.1. This is the loopback IP address is used for testing purposes. It's reserved IP address to test communication between your local device and whatever you're using that's needed, or whatever application is needed for testing. So the IP address has no physical connection to your device or a local network. It's just simply used for that only. However, in the second label there, we have ENP0S3. So this displays my local network connection with the IP address in my case here is 192.168.0.12. And so you see all of the information there in that second interface. So this is very important command that network professionals need to do, or for that matter, any developer or anyone who's working on a network, they need to identify that there are connection and any information associated with that application using that connection can use. So IP address, very useful command. This is the OSI Model network layer where we work with basic Linux networking commands and executing some basic Linux TCP dump commands. According to the documentation, the TCP dump tool is a command line packet analyzer that can print out a description of the contents of packets on a network interface. So it's important for a network professional to understand how to view the contents of packet information on a network interface using command line utilities, because many network devices require this type of interface. So to start this exercise, we're going to complete 4 things. In the first step, we're going to start and log into our virtual machine, which we are right now. We're going to get the IP address of our local virtual machine. To do that, we're just going to type in IP address, so IP space address. Here you can see on my interface EMP0S3, I have the IP address 192.168.0.12. So now that we have our local IP address, we're going to remember that. So I'm going to remember that mine is 0.12. Okay, and so then we're going to use a remote client to SSH into our local virtual machine. And you'll see that in a minute. We're going to use PuTTY in order to do that because I'm using a Windows host. If you are using a Mac, there is a separate set of instructions for SSHing from your Mac to your Linux virtual machine. So again, we will be logging in through SSH from our local Windows machine host using the client PuTTY, the client application called PuTTY. We're going to connect to our virtual machine running the Linux operating system. So to do that, we've got our IP address, which is 192.168.0.12. So what I'm going to do is I'm going to launch PuTTY here. Okay, so I'm going to launch PuTTY. So here is the PuTTY interface, and right here in the hostname field, I'm going to type 192.168.0.12, and we're going to keep the port number to port 22, which is the secure socket port for SSH. When I click open, it's going to prompt me that there is a host key that's not cached in the registry. I'm just going to go ahead and say that I trust this host key. And right now I have a local PuTTY session where it's asking me to log into my Linux virtual machine that I have running in VirtualBox. So I'm going to log in as the BDC user and the password. So now I'm logged into the Linux virtual machine via SSH from the client application PuTTY. So what I'm going to do right now is we're going to execute a TCP dump. To do that, the first thing that we're going to do is we're going to ping 8.8.8.8. So since I'm logged in remotely in this PuTTY session, I'm going to actually execute this command remotely on my Linux virtual machine. So I'm pinging 8.8.8.8, which is Google's DNS right there. And so that's going to continuously ping. So while that continuously pings, I'm going to go back to my local Linux virtual machine instance, and I'm going to execute a TCP dump command here. And I've already got that written out, and so I'm going to execute that. It's going to prompt me for my password because I'm executing it as sudo. So I'm going to put in my password. Okay, so once I do that, I grab the TCP dump. I'm going to move back over to my PuTTY session, And I'm just going to hit Control C to end that continuous ping. So that ends that. I'm going to come back to my virtual machine. So let's take a look at the output here. So in the above TCP dump output, you can see that it has packets of data, and there's a filter applied that you can see here. So we have this -C5 filter applied. You can see that right next to the command there that I wrote. It's a filter, and that filters any 5 packets. So when you look at my command that I typed, I said sudo tcp dump /i any -C5. That -C5 is saying any 5 packets. And that -NN tells me from any port. So I'm executing a TCP dump from any port. That includes the host dns.google. So we can see there all of the data that can be collected doing a TCP dump. Okay, this is the OSI model. The OSI model, we're talking here about the transport layer. In this lab, you will be using the netcat utility to start listening on a specific port within your course virtual machine. The netcat utility is used to read and write data across network connections using TCP or UDP protocols. So what we're going to do here is a 4-step process to complete this, and we're going to start by making sure that you're logged into your virtual machine, which I am right now. We're going to make sure that we acquire our local IP address. So remember the local IP address command. We're just going to type IP address. And you're going to make note of your local IP address. So mine is on ENP0S3 interface. My local IP address is 192.168.0.12. And so what we're going to do is we're going to run this netcat utility command using this command. And so I've got it pre-written here. And so what we're going to do is we're going to run the netcat on port 12345, right? So I'm going to go ahead and execute this command. You won't see anything happen. So what's happening with that -L is that the utility is in listen mode. So it's listening for any input connections. And the -P specifies the port that we're listening on. So right now we are listening on port 12345. So what we're going to do is we're going to start a telnet session, and we're going to telnet and we're going to transfer some data. And to do that, now it's also notable that as I demonstrate this, it is not recommended that you do this in practice, because this is a very unsecure way of moving data unencrypted. So what I'm going to do is I'm going to telnet to 192.168, my virtual machine, .0.12 on port 12345. So when I do that, I have an open telnet session. And then everything that I type in my telnet session locally, so I'm locally in my command prompt in Windows, and I've telnet to my virtual machine, and everything that I type is now visible and captured right here because I'm listening on 12345. One, two, three, four, five. So I'm typing. Okay, so I'm just going to close that telnet session. I'm just going to close it here, and so the connection is canceled, and it right there takes me back to the command prompt right there in my virtual machine. So what we're going to do this time is we're going to take it a step further, and we're going to run the netcat utility, and we're going to capture data in a file as we're running it. So what I'm going to do this time is I've got the command pre-written here, and I'm going to run a process right there on port 12345 using my netcat utility. And I'm going to take all of the data that's transferred on that port to a text file called get_data.txt. And that will get stored in a directory of my choice. I guess before we actually do that, let me navigate. Let's look, we're currently in our root directory. I'm going to change my directory to my test directory. Okay, so now let's go ahead and start this process. And we're going to go ahead and output it right there to get data.txt. So I'm going to go ahead and do that and execute. Nothing happens when I hit the enter key on my keyboard. So I'm going to go back to Windows, and in Windows I'm going to run the command prompt. I'm just going to type cmd from the command right there, the command bar, and it launches the command prompt for Windows. And I'm going to telnet to my virtual machine 192.168.0.12 on port 12345. Now this time what's going to happen is I'm going to type some text and it's going to be captured and stored in a text file. So I'm just going to say this is a test of capturing data. Okay, and I'm going to stop that. And it kills the connection to the port, and I'm going to type ls, it's going to list the contents in the test directory, and you can see that there is the get_data.txt. I'm then going to open the get_data.txt file with nano, get_data.txt, and there you can see that is what I was typing in my keyboard with the telnet session. I typed this as a test of capturing data. So we were able to capture that data inside of a text file. So again, it's important to know that this is generally an unsafe practice to create a session using a random port that will accept any connections from anywhere. It's also generally unsafe to use the telnet in an open network connection because text can be intercepted with no secure transfer. So this lab is a good learning experience and clearly demonstrates the cybersecurity risks involved when using unencrypted open data transfer on open connections. So this is the OSI model application layer. So it is a common task for network professionals to start and stop application services so that they are available for users in a networked environment. So in this lab, you will be creating an HTML web page in the /var/www/html directory of your course virtual machine. Of course, that's the directory where Apache web server finds its files. So what we're going to do here is go through 4 steps, and we're going to start and log into our virtual machine, which I've already done that here. We're going to get the local IP address of our virtual machine. So remember to do that. We just type IP address. So here you can see on EMP0S3 interface, my local IP address is 192.168.0.12. So now that we do that, now that we've done that, we're going to navigate to the /var/www/html directory. So I'm already there. If I were here at the root directory, which is maybe where you are, you would just type cd/var/www/html. So there we are, we're in our root directory. If I type the ls command, you can see that I've already created the test.html. So for the purpose of this demonstration, I went ahead and pre-created that file. And remember, this is a restricted directory. In a previous lab, we demonstrated how you would have to create files in a restricted directory by using the sudo command touch test.html here. So what we're going to do is open this up in nano so you can see it. So if I type sudo nano test.html, you can see here is the file, and I have it in edit mode. I can make a change. So this is the HTML file, and what you see here is a standard HTML encoding. So these are tags so that it can be displayed inside of a web browser. So now that we see that file, I'm going to go ahead and exit out of that. So what we're going to do here is the next step is we're going to start our web server, and we're going to start the Apache web server so that we can view this HTML file inside of our local browser on our Windows machine. So I've already got that command pre-typed here. So sudo systemctl start Apache 2. I just hit return. You don't really see anything happens, but that's the command that starts the Apache web server. So what you do is you jump out of your virtual machine and you open up a local browser. So I've got Firefox here open, and what I'm going to do is I'm going to type http:// and then the IP address of my virtual machine. So my IP address is 192.168.0.12. Now when you just type that, this is the test file that's included, the default file that's included in the Apache web server directory, that /var/www/html. That's the index.html page, and it just verifies, hey, yes, Apache is running and working. So in that same root directory, if I just do /test.html, here is the HTML file that I had stored in that directory that I created. So my name is Clinton Daniel, and this is my web page. And applications can be implemented using the web server. So it says we applications can be, so I could make that correction if I wanted. So I'm just going to close this up. I can stop my web server by doing this command here that I have already right there, stop Apache 2. And that stops the web server. So I had a spelling error, so I could just right here type sudo nano test.html, and I could come down here, instead of saying we applications, I want to say web applications, right? So web applications can be implemented using the Apache web server. So I hit Control X. Do I want to save it? I type yes. Save over the file, hit return. Clear. So I'm going to restart my web server. Sudo systemctl start Apache 2. I'm going to go back to my local Firefox web browser on my Windows machine. And Firefox is going to open. And again, I'm going to type http 192.168.0.12/test.html. And there you can see is the corrected web page. Web applications can be implemented using Apache web servers. So again, this is a great example of how to start and stop web services on a Linux application, right? A Linux instance, using your virtual machine.